2,
See, that's all was missing.
3, 2, 1.
All right, class, tonight we're going to talk about mastering the robot. This is IMT 200, Jefferson Community College, Louisville, Kentucky. We're going to go over the Cert, Fanuc Cert training. My name's Henry Garrett. As I said, this is going to cover mastering the robot. When the servo is changed or the backup batteries have died, causing loss of positional data, the robot will need to be mastered. We can come across this when we're changing a servo. We've lost power in the batteries. We're not able to maintain the firmware in the controller. We have 4 types of mastering that we can restore this. We have the fixture position mastering, the 0-degree mastering, single axis mastering, and the quick mastering. Fixture position mastering, the advantage, it's going to be very accurate. The disadvantage, it's time consuming. And we need to have a fixture purchased from Fanuc to use this procedure. 0-degree mastering, the advantage is quick. Disadvantage, it's not as accurate as fixture position mastering. And the procedure requires us to have the witness marks available, and we'll align the witness marks and master it at 0 degrees. Single axis mastering, we're going to use this when a motor is changed or mechanical work is done. Advantage, it can provide a reteaching, it can prevent reteaching of points if done correctly upon loss of mastering in one axis only. Quick mastering we can use when the controller has lost data due to only power loss. The advantage, we don't have to touch up our points. Disadvantages, we must set this up prior to loss of mastering. And it cannot be used in all cases. So when we master a robot, we're going to find the physical location of the robot by synchronizing the mechanical information with the robot's positional information. Robot must be mastered to operate properly. Robots are usually mastered before they leave Fanuc America Corporation. However, it's possible the robot might lose its mastering data and need to be remastered. The robot axes are controlled by a closed-loop servo system. The controller outputs a command signal to drive each motor. We get a feedback. The device is mounted on the motor. It's called a serial coder, and it sends a signal back to the controller. During robot operation, the controller constantly analyzes the feedback signal and modifies the command signal to maintain proper location and velocity of the end effector at all times. For a robot to move accurately to record the positions, the controller has to know the position of each axis. It does this by comparing the serial pulse coder readings during operation with a reading taken at a known mechanical reference point on the robot. Mastering records a serial pulse coder reading at a known mechanical reference point. This mastering data is stored with other user data in the controller and maintained when the controller is shut down. When the controller is shut down under normal conditions, each pulse coder's present reading is maintained in the pulse coder by backup batteries on the robot. This is a picture of a pulse coder on the screen. When the controller is turned on, the controller requests a stored reading from the serial pulse coder. When the controller receives the pulse coder reading, the servo system can operate normally. This process is called calibration. Calibration occurs automatically each time the controller is turned on. when the pulse coder backup battery power is interrupted while the controller is powered down, calibration fails at power up, and the only robot motion possible is joint mode jogging. When calibration has failed, the Axis software travel limits will be ignored, allowing the robot to be jogged further than normal. We must be careful when jogging the robot in an uncalibrated condition, or you could injure personnel or damage equipment. To restore proper operation, the robot must be mastered and recalibrated. Before mastering a robot, you must clear any faults that prevent servo power from being restored or that prevent mastering completion. Okay, since we've lost power, battery power during a shutdown or something, and we have the alarms, we need to reset our alarms and prepare the robot so we can continue mastering it. So when we turn on the robot after the pulse coder backup battery power has been interrupted, you will see an SRVO-062 BZAL alarm, and you also might see a servo SRVO-038 pulse mismatch alarm. Before we can master the robot, we need to reset these alarms. And we need to rotate the motor axis that lost the battery power to prepare the robot for mastering. So first, if necessary, we need to replace the robot batteries with 4 new 1.5 volt alkaline batteries, size C. You'll see this on the left, it's LR14.C. We'll observe the direction arrows in the battery box for proper orientation of the batteries when we replace them. We also may need to replace the controller battery located in the front door of the controller. There's a picture of it on the right there. Just unplugs, and Fanuc recommends this every 4 years. The part number is the A98L-0031-0028, which you can order from Fanuc. So if we replaced our batteries, we're going to go to our menu screen. We want to select System. We're going to press F1 for Type, and it'll bring up this screen. We want to arrow up and down until we find the $master space E and B. And since it's not showing up on the previous menu, because it's a 0, we need to enable it. So this is a screen that will come up. As you see, it's not showing on this menu selection. If it was showing, we can go straight to step 6. But since it's not showing, we have to enable this command. So we want to click over on our variable tab. This will bring up our screen. So you want to scroll through till you find the $master enable. As you see here, it's set to 0. We want to enter a 1 in our teach pennant to enable it. And once I do that, you'll notice that the master enable is now 1. So we want to press F1 and type. So now we have our master calibration is showing. So if we skip to step 6, we should be here. Our master cal screen. When we click that, we'll see a screen similar to the one shown. Just notice it has a fixture position master, the 0 position master, a quick master for single axis master, quick set master, and calibrate. So to clear the alarms, I want to press F3 or the RES-PCA button. Here should bring up a screen. You'll see at the bottom, reset pulse coder alarm. It says no. But I want to click on F4 for yes. And that will reset my alarm. Now we want to power down the robot. Once it's powered down, wait a few seconds and power it back up. If the servo SRVO-062 BZAL alarm is still present, there's a battery cable or pulse coder problem, refer to the system R-J3 controller series electrical connection and maintenance manual for further information. If a servo SRVO-38 pulse mismatch alarm is present at this time, repeat steps 1 through 8 to reset it. It's not necessary to restart the robot after resetting to clear this alarm. We will rotate each axis that lost battery power by at least 1 motor revolution in either direction. Failure to do so will result in the SRVO-075 pulse not established alarm reoccurring, and mastering will not be possible. For each rotary axis, we want to jog at least 20 degrees. For each linear axis, we want to jog at least 30 millimeters. If the servo SRVO-075 pulse not established alarm is present at this time, press reset to clear it. Next, we will perform any of the mastering procedures from the Master Cal menu. Next, we're going to talk about mastering the robot to zero position. This is a procedure that we're going to use to position any of the robots in the classroom here. We're going to use the witness marks on the robots to master our robots and calibrate them. So we master to 0 degrees, we position all axes at their 0 degree witness marks and record their serial pulse coder readings. The procedure we're going to use to accomplish this, we're going to jog each axis of the robot in a joint to the witness marks. We'll press menus, select System, press F1, and select Master Cal. So some of your robots will have these tick marks on them to align the axis. Our robots in here, we actually have scribe marks or witness marks on each robot joint to align the trainers back to. Once everything is set to 0 position, your robot should look something similar to the picture on the right. So first thing I want to do, I want to jog and line up my J1 witness mark. Next, I want to jog and line up my J2 witness mark. Next, I want to jog and line up my J3 witness mark. Next, I want to jog and line up my J4 witness mark. Next, I want to jog and line up my J5 witness mark. Then I want to jog and line up my J6 witness mark. So once I have everything lined up and all my witness marks, double check everything, make sure they look good, then I'll press menus. I'll find the System tab. Since we went through and enabled the master calibration function previously, it's now showing up on under the System tab. We'll press Master Calibration. We'll click on Type, F1. As you see here, it gives us, again, all our options for mastering. We're going to select 2, 0 master position. See, master at 0 position, no on the screen. We're going to click on yes. After mastering, calibration must be done. Calibration tells the robot to update its current position to agree with the new mastering data. So we'll go back to our screen here. We'll click 7 for calibrate. Once we do that, the robot's calibrated. We can also use one of the other methods to calibrate the robot, such as fixture positioning master, single axis mastering, and quick mastering. Once we calibrate a robot, we need to verify proper operation, make sure everything is working properly. And that's the end of my presentation.